Welcome to the video on organic chemistry nomenclature. This video will be a summary of all the nomenclature that we'll need to know for organic chemistry. The International Union of Pure and Applied Chemistry, or the IUPAC, has come up with a systematic way to name organic compounds. This is an effort for everyone to always be talking about the same thing. We can have a very complicated organic compound, but we need to be able to name it so that everyone knows exactly what we're talking about. And so here is an overview of the nomenclature set up by the IUPAC. Organic compounds are named so that there's 5 parts to the name. It starts with stereochemistry. We will learn this in chapter 5. The second part of the name is going to be the substituents. And so these are going to be groups that come off of the main chain. The third part is going to be the parent chain, and that is the longest carbon chain, including the important functional groups. Next, we have our degrees of unsaturation. In this case, we talk about alkenes and alkynes, meaning we have double bonds and or triple bonds. And then finally, the suffix at the very end of the name is going to indicate what functional group we have in our molecule. All IUPAC names follow this pattern. This slide shows a step-by-step protocol in order to name any organic compound. The first thing we're going to do is identify the parent chain and number it. The second thing we need to do is see if there are any stereocenters in our molecule and find out where they are. Again, we will cover this in chapter 5. The third thing we will do is to determine if there is any unsaturation in our molecule and where that unsaturation begins. By unsaturation, I mean double bonds and triple bonds. The fourth thing we will do is identify if there are any functional groups in the molecule and determine where they are. The fifth thing we will do is identify and name any substituents that are on our molecule and where they are located. What we are going to do for this is to put the number and the name of each substituent before the parent chain name in alphabetical order. If there is more than one of the same substituent, we are going to use the prefixes di, tri, tetra, penta, etc. Note that di and tri are ignored when alphabetizing substituents. And the sixth step is to put it all together. Now, this may seem a little overwhelming, so what I'm going to do is march you through examples of all of the functional groups and show you how we can follow these steps. Alkane molecules, just carbon and hydrogen, no double bonds, no triple bonds, are the simplest to name. In this case, we can skip some steps. The first thing we are going to do is identify the parent chain. That is the longest continuous carbon chain. The second thing we are going to do is identify the substituents that are off that parent chain. Once we find the substituents, we are going to be able to do number 3, which is number the parent chain and assign a locant or a position to each of the substituents. Finally, we are going to list the numbered substituents before the parent name in alphabetical order. Here is a table that will show you how to name the parent chain. If our longest carbon chain is 1, then we will use the parent name meth. 2 is eth. 3 is prop. 4 is bute. 5 is pent. 6 is hex. 7 is hept. 8 is oct. 9 is non, 10 is dec. I think you can see for these, we can use our geometry terms if we're having a hard time memorizing these. Here's the term for some of the important ones, 11 and higher. The ones listed 1 through 10, you're required to know for this course. Here is an example. The first thing we have to do is find our longest continuous parent chain. And so although you may kind of jump right here, I have to show you that that would be 5 carbons. If you do this direction, then that is 6. And so the correct answer for the parent chain in this compound is in fact 6. And so we're going to have the parent name, which is hex. It's all single bonds, so we're going to have ane. So hexane is our parent name. Step 2 is to identify all substituents, and here is our substituent. There's only one substituent on this 6-membered parent chain, and that is this carbon right there, which we will call a methyl group. And if we're going to number our parent chain, we want to number it from the end that is closest to the substituent. So this is going to be 1, 2, 3, 4, 5, 5, 6. So in fact, our substituent is on carbon number 3. We're going to pull that together and name our compound. We have a methyl group at carbon 3. And so that is going to be 3-methyl. And then we put it together in one word. And so the full name of this compound is going to be 3-methylhexane. Now in our second example, if we find the longest parent chain, and so here is our longest parent chain. And so our parent name is going to be heptane, but even more correctly, it is cycloheptane because our 7 carbons form a ring. This is going to have to be our carbon 1 because that is where both substituents. So off of carbon 1, we have 2 methyl groups. And so the way that we are going to put this into our name is that we have on carbon 1, we have a methyl group, and then on carbon 1, we have a methyl group. And so it is going to be 1,1-dimethyl cycloheptane. And that's all one word. And so that is our answer. If we look down to the third example, if we look at our parent chain, it is 4 carbons long. And so our root is going to be butane. If we identify the 2 substituents, we have a bromine here and a bromine here. And so we're going to have to identify where those are. We can number it either starting from this end or this end to give us the bromine on the second and the third. It doesn't matter which end we start with because it's tied. And so on carbon number 2, we have a bromine, and on carbon 3, we have a bromine. Because bromine is the same, we're going to use dibromo, but in this case, it is on carbon 2 and 3. And so we'll do 2,3-dibromobutane, 2,3-dibromobutane. If we move on to alkenes, remember alkenes are carbon-carbon double bonds, and alkynes, remember those are triple bonds. We will learn how to name these compounds here. And remember, these are going to be examples of unsaturation. Alkenes and alkynes are given IUPAC names very similar to the procedure we use with alkanes, with just a few minor modifications. The modifications are underlined in the following text. The first thing we are going to do is identify the parent chain, but in this case, the parent chain has to include the double bond or the triple bond. The second step is the same, identify and name the substituents. The third step is we have to provide a location for all of our substituents, but also for where the double bond and or the triple bond starts. Those numbers for our double bond and our triple bond have to be the lowest number. So we're going to start numbering closest to the end where the double bond starts or the triple bond starts. Then we're going to list our substituents in alphabetical order. We're going to ignore prefixes except for iso and cyclo, and we will get to that a little bit later. Iso is a prefix used sometimes to identify side chains, and cyclo is when you have a substituent that's a ring, and so we'll get to those later. Iso and cyclo are included when putting things in alphabetical order, but the di, tri, tetra do not count in alphabetical order. If it's a dibromo, then it's the B that we're going to use, not the D. And lastly, we are going to change the suffix from ane to ene if it's a double bond, or yne if it's a triple bond. Then I also want to tell you, when we describe where the double bond or the triple bond starts, we can add that into the name either just before the parent name or just before the ene or ein suffix. Okay, so let's practice. Our longest parent chain here, including the alkene, is this one here. So we have a carbon chain that is 5 carbons long. And then we identify substituents. And so we have a single methyl group here. And then if we number our chain, giving the double bond the lowest number, we're going to start here. And so our parent name is going to be pentene. And our substituent is at carbon 2. So we're going to call this 2-methyl. And then we can put the 1, which is where the double bond starts. We can put the 1 in 2 places. So it is acceptable to write the following 2 answers for this question: 2-methyl 1-pentene or 2-methyl pent 1-ene. It is a convention to use a dash anytime there is a number next to a letter. Our longest carbon chain here is 3. Remember, we have a carbon here, a carbon here and a carbon here. So that's 3. That's going to be prop. And because this is a triple bond, it's going to be propyne. And we have to look and decide where our triple bond starts. We're going to number it 1, 2, 3, because that will start the triple bond at the position 1. So this is going to be 1 propyne, or we can write it as prop 1-ine. And again, either one of those are acceptable. Now, if we move on to the nomenclature of alcohols, again, they're very similar to alkanes with minor modifications, which are again underlined here. For alcohols, what we have to remember is when we identify the parent chain, it has to include the carbon that has the alcohol on it. Again, we're going to identify and name the substituents, assign a locant to each substituent. We're going to number the carbon chain in such that the alcohol gets the lowest possible number. We're going to list the numbered substituent before the parent chain in alphabetical order, and then ultimately the OH locant is placed either just before the parent name or just before the OL suffix. So that's a key point. The E becomes OL for an alcohol. So that's the OL suffix. Now, if we try a couple practice examples, this one here is highlighted. In pink, we have our parent chain, which is 7 long, and that is going to be hept. If we identify our substituents, we have an OH group and we have a propyl group. Remember, propyl is 3. So we have an OH and we have a propyl. It's been numbered here for you. So we see that the OH comes off of carbon 2 and the propyl group comes off of carbon 3. And so if we were going to start putting this all together, remember, we have to start numbering from the end that's closest to the OH group. And that's why this one is carbon 1. And so the ending of the name, the ending of the parent is going to be heptane all. OL, so heptanol. And now we put our substituent. And so on carbon number 3 is a propyl. So it's going to be 3-propyl heptanol. But we need to indicate where the OH is. So we can place the position of the alcohol, the locant of the alcohol, either before the parent name or before the OL designation. And so both of these are correct. Now in the next one, if we pick our longest carbon chain, it's going to be there. And if we identify our substituents, we have those 2 groups. And if we number the parent chain, this has to be 1 because we want our OH with the lowest number. And so if we put this all together, our parent chain is butane all or butanol. And remember, we have our substituent at carbon 3, 3-methyl 2-butanol, or 3-methyl-butane 2-all. In order to talk about nomenclature of amines, we have to give a little bit of background first. Amines are all derivatives of ammonia, and in some cases we have the nitrogen that has 1 R group or 1 carbon attached. That's primary. In some cases we have 2 R groups attached. That would be a secondary. And in other cases we have 3 R groups attached. That would be a tertiary amine. For primary amines, it's very simple, and it's very similar to the way that we've been naming everything thus far. Our amine is going to be coming off of the parent chain. We find the longest carbon chain shown here, and there's 7. And so this molecule is going to be hept. We identify all of our substituents. We have an amine there, we have a methyl group there, and we have a methyl group there. For the record, this dashed species right here indicates stereochemistry, which we have not learned yet. For now, we will skip that piece. Our longest parent chain is 7, so that's hept. We have a methyl group at carbon 6, and we have a methyl group at carbon 4. And so we're going to name that 4,6-dimethyl. And then we have hept. We have to now give the suffix as the amine. And so if we put our amine ending at the end of this name, is going to be heptane amine. For an alcohol, we would have put OL, and now we're going to put amine. The only thing is we need to indicate where the amine is. And so we're going to put a 2 right here. So the full name of this compound is going to be 4,6-dimethyl-2- heptaneamine. So that is the final answer. Please note that we have the dashes anytime we have a letter by a number. However, whenever we have two numbers next to each other, we are going to put a comma. This naming works for primary amines only. A little bit more information about primary amines. If we have an amine that is a substituent, so the alcohol is the parent chain, the alcohol gets the suffix, and so the amine is a substituent. Same here, this benzene ring with the carboxylic acid is a parent name, and that is going to be benzoic acid. So in both cases, we're going to use the term amino as a substituent. For this case right here, we have a 4-carbon chain, so that's going to be butanol, and we put a 1 there to indicate that it's on carbon 1, and then we have 4 amino. And here, benzene is 6, so here we have 4 amino benzoic acid. And then also, I wanted to tell you that if you have benzene with an NH2 on it, that has a common name of aniline. You'll see that we can then name substituents in addition to that. But just know that benzene with an amine is aniline. Now, if our amine is a secondary or tertiary, then we have to do things a little bit different. If we have a secondary or tertiary amine, we need to name the alkyl group followed by amine and use di, tri, or tetra if there's more than one of the same group. And if we look at this first example, we have ethyl, methyl, and propyl, all 3 groups coming off of the amine. So we would put that in alphabetical order, and we would call that ethyl methyl propylamine. In this case right here, we have 2 ethyl groups, and so that is going to be diethylamine. And similarly here, we have 3 methyl groups, and so that's going to be trimethylamine. And these are more the common names. If it gets more complicated than that, then we are going to have to identify the longest carbon chain that's on the nitrogen, and that's going to be our parent. And so in this case, that is butanamine. And then if we name our substituents, and our substituents are a methyl and an ethyl, and so we have a methyl and an ethyl. Instead of putting a number, the methyl group and the ethyl group are not attached to a carbon. They are in fact attached to the nitrogen. What we're going to call this is N-ethyl and methyl butanamine. These N's just mean that the ethyl and the methyl are attached to the nitrogen. And the reason that there is a dash there is because the N is a locant. So when we use N in this way, we're going to use a dash. And again, alphabetical order, we put ethyl before methyl and then butanamine. And so there's how we name amines. And if we're going to name aldehydes and ketones, some of the things are exactly the same. We find the parent chain, we name the substituents, we look at the locant of the substituents, and then we put everything together alphabetically. The only thing we need to worry about with ketones and aldehydes is that for aldehydes, we take the E off the ANE ending and put in AL. Do not get this mixed up with alcohol, which is OL. Aldehydes are AL. Secondly, the parent chain must include the carbonyl group. Also, the aldehyde needs to be put at position 1. So when you're numbering the parent chain, the aldehyde is carbon 1. If we look at ketones, we're going to replace the E at the end of ANE with ONE. So that's where we get the ketone. Parent chain has to include the carbonyl again, and the carbonyl is given the lowest possible number. And again, it can be expressed before the parent name or before the suffix, just like alcohols and alkenes. So if we're going to practice, our longest parent chain is 5, and so our parent name is pent, and this is pentanal because it's an aldehyde. If we look for our substituents, on carbon 3 we have a chloro, so this is just going to be 3-chloropentanal, and we do not have to indicate the position of the aldehyde because it is on carbon 1. If we look at our second example, we have an aldehyde and a ketone, and so this parent name is going to be butanal, and we have a substituent here which is a ketone, and I haven't told you this yet, but when a ketone is a substituent, we're going to call it oxo. Anytime the word oxo is a substituent, it means a carbonyl on that carbon. And so on carbon 3, we have oxo, butanal. Our longest carbon chain here is 5, but it's a cyclo, and so it's also an ene. And so if we number the carbons, we have pentane and we have an one and we have an ene. Plus we have cyclo. And the way that all fits together, because the unsaturation is second to last and the functional group is last, we have cyclopentane with an alkene starting at carbon 2 and a ketone at carbon 1. Just a couple extra things about ketones and aldehydes. This is stereochemistry, and we'll get to that in chapter 5. An aldehyde that is a substituent is going to be called carbaldehyde. The way that I remember that is it's an aldehyde, and the parent chain does not include the carbon of the carbonyl, and so we're going to add carb, meaning there's an extra carbon in that. Here's some common names. We have formaldehyde, which is the easiest aldehyde. We have acetaldehyde, and then we have benzaldehyde. Again, benzene with the aldehyde on it. Carboxylic acid nomenclature, we're going to take the E off of the alkane and add oic acid, and the carboxylic acid has to be at carbon 1. So if we're to name this compound right here, our longest carbon chain is 4, so that is going to be butanoic acid. The carboxylic acid is at carbon 1. If we're going to name this compound, our parent chain is 5, and so carboxylic acid wins. So our substituents are going to be the alcohol, the 2 methyl groups. So carboxylic acid's always 1, and so our parent chain here is pentanoic acid. We have 5 hydroxy and 4,4-dimethyl. So hydroxy comes first. So when OH is a substituent, it's called hydroxy. So this would be 5-hydroxy 4,4-dimethyl pentanoic acid, and that's the answer for that one. Now, if our carboxylic acid is a substituent off of something else, like this is cyclohexane, carboxylic acid is going to be the substituent. So we're going to name this one right here, cyclohexane carboxylic acid. Shown here also is common names for carboxylic acid. So we have formic acid, acetic acid, propionic acid, butyric acid, and benzoic acid. I also want to tell you that if there's more than one acid, obviously it has to be at the 2 ends because the carboxylic acid has to be at the end. And so this would be pentane dioic acid. If we were to name this one right here, the longest carbon chain is 3. And so that is going to be propanoic acid, but we have to talk about the substituent as well. So this is going to be carbon 1, 2, 3, 2-methyl propanoic acid. So if I just bring it home with the last few functional groups that we need to know how to name acid halides. And this is a carboxylic acid derivative that has a halogen on it. So it's an acyl halide. We replace the ic acid of a carboxylic acid with YL halide. For example, acetic acid, shown here, if we have the bromine there instead, it becomes acetyl bromide. Benzoic acid, shown here, becomes benzoyl chloride. When we name esters, C double bond O with an OR, so that's an ester. If we're naming an ester, we replace the carboxylic acid's name with the suffix ate. So if we have acetic acid, it becomes acetate. And then at the beginning of the name, we have to put the R group, the name of the R group that is attached to the oxygen in the ester. So this would become ethyl because there's an ethyl group there, acetate because this was acetic acid, but now it's acetate. When we're naming amides, we want to replace the ic acid from the carboxylic acid with amide. So shown here is acetic acid, that becomes acetamide. Benzoic acid becomes benzamide. And just like with amines, if there are additional carbon groups on the nitrogen, we're going to use N-methyl for this methyl group, or N-N-dimethyl for these 2 methyl groups. I will not ask you to ever name nitriles, but if you see this name, then you'll recognize it as a nitrile. We replace the ic acid or the oic acid of a carboxylic acid with onitrile. So if we have acetic acid, it becomes acetonitrile. Now that is a common organic solvent, so you should probably be aware of that one. Benzoic acid becomes benzonitrile. And if we can kind of pull all of the things I've just talked about together in one slide, it's shown here. As I introduced alkenes, I said they get the highest priority, they get the lowest number. Then I introduced alcohols and I said, no, these guys get the lowest number. And then when I said aldehydes and carboxylic acids, those always got carbon 1. So which one is the most important? And this table sums it up. The most important functional group, priority-wise, in terms of nomenclature, is carboxylic acid is the highest priority functional group. It gets carbon 1 no matter what. Anything in addition to that on the molecule follows suit. Carboxylic acid is carbon 1. And the ending or the suffix of the name is oic acid or carboxylic acid if it's a substituent. And the prefix used for carboxylic acid is carboxy. Next comes aldehyde with the al suffix. And again, if it's a ring with an aldehyde off of it, it becomes carbaldehyde. If the aldehyde is a substituent, it becomes oxo or formyl. Next is a ketone with the suffix of one. And just like aldehydes, if it's a substituent, it's oxo. Next comes alcohol with the suffix of ol, and if alcohol is a substituent, it's going to be called hydroxy. Next is an amine with the suffix amine, and if the amine is a substituent, it becomes an amino group. Finally, we have alkene with the suffix ene, and alkyne with the suffix ine. And lastly, if we have an alkyl group, that's NER group. If we have an alkoxy group, that's an OR group, and that makes an ether. And then we can have fluoro, chloro, bromo, or iodo as the halogens attached. So I thought this table was a really nice summary. I love how it puts everything in perspective in order of importance in terms of priority. I love how it summarizes all the suffixes that we're going to use. Also, if it's a substituent, what it's going to be called. It gives us some structures shown here as well. I just thought this was a great summary for nomenclature. And I apologize. This is the longest, most boring video I will ever make. Nomenclature. We have to know it. I have to teach it, but it's not fun. Okay, in class we'll have lots of practice problems. There you have it, nomenclature.